Here at the National Center for Supercomputing Applications, members of the Students Pushing Innovation, or SPIN program, are given the opportunity to work with mentors to create various projects. This year's Virtual Reality and Ray Tracing for Computational Materials Science project group developed a software that can model several molecules in a three-dimensional space.
Caught my interest because for us in material science, it's always difficult to find people with very specific software development skills.
We're building a data visualization application using virtual reality to show different molecules that are being used in research. So these materials that we're using are by far crystal lattice structures, and what we want to do is we want to show them in VR.
Avogadro to model atoms and molecules, as well as the electron density. We're also using Vesta, which is like a crystallization molecule viewer. And then we're using those files, we put them into Blender, and then in Blender we change their protein bank data files that we can load into Unity.
Each member of the team contributed to improving the application of the software through Google Daydream, Cardboard, Oculus, and the Microsoft Mixed Reality headset. The final product was a versatile virtual reality application.
In the application, there are 3 or 4 main functions. One of them is the user could move around the molecular structures they see. They can also rotate those atoms. They can also minify and magnify these atoms and take a closer look at the inner structure.
Right now our project is intended to be educational. We'd like to have students, university students, and also the public to look at this application and understand these different materials and understand what they're looking at. So our goal is to expand the learning aspect of it by perhaps including more of an interactive learning experience rather than just a visualization.
The unique character of the SPIN program as a whole is that we combine people, students from different disciplines. And so the unique aspect of it, which benefits everyone who's participating, is that people get to speak each other's language. That is something that does not happen very often, but the project that we're working on requires this interdisciplinary character, and so that helps the students because they are exposed to research problems and research questions that they normally would not be exposed to, and it also helps them to work in teams, to talk to each other, and to work together to solve these kind of problems that we're working on.